So let's discuss the second question based on our first lesson. In this question, it's given to us that p is a positive integer. So p is greater than 0 and it can take any values such as 1, 2, 3 and so on, right? So if you want, you can write it down if you want to, some values. Now I need to find out what is the remainder when p square minus 1 is divided by 8. So I need to figure out the remainder. Now, once again, it's very tempting to leave the statement, to leave the question as is, and jump into the statements. But let's spend again 30 seconds and think if we can do anything about it. Now, ideally, when you see an expression like p square minus 1, p square minus 4, x square minus 1, you should be able to infer that they're asking you to use the standard identity a square minus b square is a plus b times a minus b. In this case, p square minus 1 can be written as p square minus 1 square. Again, a very common expression which is used by GMAT. And that means this p square minus 1 can be written as p plus 1 times p minus 1 divided by 8. Okay. Another thing here is, whenever you are asked the divisibility of, say, 2, 3, 6, 8, it sometimes it deals with the nature of the number, whether it's an even number, an odd number. Okay, so if you want to find out the answer, what you can do is you can try and think a little bit whether you can say anything about p plus 1 or p minus 1. Now notice an interesting thing here. If this p minus 1, if I put p here, okay, p is the because p is a positive integer, p plus 1 is a number which is just above it, and p minus 1 is a number which is one below it. Okay, so p minus 1, p plus 1 are three consecutive integers. Now what is the significance of this? Well, any three consecutive integers, okay, if out of any three consecutive integers, here's an interesting thing that can happen. So this p out here, if this p turns out to be, say, odd, okay, if this p turns out to be odd, then p minus 1 and p plus 1, they both end up being even, right? And if p turns out to be even, let's write down both the cases, it makes sense to do that, then p plus 1 is odd and p minus 1 is also odd. Now, you might wonder what exactly is happening here. Well, what I'm trying to say here is, and if you know this or not, that if you have three consecutive numbers, out of which two of them are even, then one of them is divisible by 2 and the other one is divisible by 4. And let's take a few examples to understand this. And let's take this case, 2, 3, 4. Okay, so this is p plus, this is p minus 1 and this is p plus 1. 4 into 2, 8, right? So this 4 into 2, 8 is divisible by 8, so the remainder is 0. Then take another case, let's take 8, 9, 10. Obviously this is also divisible. Let's take 14, 15, 16. So you take any case, you'll notice one of them is definitely divisible by 2, other of them is definitely divisible by 4 and sometimes 8, depending on what you're taking. But the idea is p minus 1 and p plus 1, when you multiply them, take any case, they are always divisible by 8. And in this case, if p turns out to be odd, in this case, the remainder is 0 every time. Okay. In this case, when p turns out to even, these two are odd. So now here you need to check whether you can get a unique answer or not. What you'll notice is that you don't get a unique answer. So for example, if I take 5, 6, 7, okay, in this case 7 times 5, because this is p minus 1, p plus 1 is 35. 35 and divide by 8 gives you a remainder of 3. Okay, let's take 11, 12, 13. Okay, in this case you have 11 times 13 by 8, right? And how much will you get? Is this completely divisible? You'll notice it is not. Either you can multiply and find 143 by 8, or what you can do is you can simply find out the individual remainders, which would be 3 and 5, and then say that the remainder is 7. Up to it's up to you what method you want to use. But the point that I'm trying to make is, then when a p is even, the remainder can be anything depending on what p minus 1 and p plus 1 is exactly. So I need to know the exact value to figure out what will be the remainder. Okay, but when p is odd, then p plus 1 and p minus 1 are both are even. In that case, I can very confidently say that the remainder is 0. So if you do this analysis, then it will be very easy for you to look at the statements and figure out whether you can get the answer or not. And let's see how. Let's take the first statement. The first statement is p is completely divisible by 3. So p is completely divisible, no remainder. Now notice in this case, p can be even, such as 6, 12, and so on. So if it is even, I will not be able to find out my answer. And if p turns out to be odd, like p can be 3, p can be 9, p can be 15, in this case I know that the remainder would be 0. But I cannot confidently figure out what p is, whether p is even or whether p is odd. I don't know that. Okay, and since I don't know that, it is not possible for me to find out the answer using the first statement. So this statement is not sufficient. Okay, so your answer cannot be A, your answer cannot be D. And notice how quickly I can look at each statement and get my answer, because I've done my pre-analysis properly. I'm not spending much time on my statements because I know what I need to do. The second statement is p leaves the remainder when divided by 2. So when p is divided by 2, I'm getting remainder, and the only possible remainder is 1. You know that. So if I'm getting a remainder here, that clearly means that p has to be an odd number, right? Because if only odd numbers when divisible by 2 leaves a remainder. Okay, now if p is an odd number, we have done a pre-analysis. We know that in case of odd number, we don't need to know the exact value of p. We can very confidently say that if p is an odd number, then p plus 1 and p minus 1, they are both even, and their product is always divisible by 8, as can be seen in all these cases. Okay, thus the answer in this case will be option B. Now, some of you may even wonder, we are taking values. How can you be sure that this is correct? Okay, that's quite possible. Some of you may think in that way. So I just want to show you another way of solving this question, and I won't discuss it elaborately, but just very briefly to show you how without taking values also you can figure out that if p is odd, then p plus 1, p minus 1 is divisible by 8. And let's do that very quickly here. Okay, let's say if p is odd. Okay, if p is odd, then p can be written as 2 plus 1 or 2 minus 1, right? Okay, now I know if p is, let's take one case, p is say 2n plus 1. If p is 2n plus 1, then what will be p plus 1? P plus 1 will be 2 times n plus 1, right? What would be p minus 1? P minus 1 would be 2n plus 1 minus 1, which is 2n. Now notice if I take p plus 1 and p minus 1, I get 2 times n plus 1 times 2n divided by 8, which is 4 times n plus 1 by 8. Now notice n and n plus 1, they are consecutive integers, right? So one definitely has to be even. If one definitely is even, then that means I will be able to cancel this, and out of these two I'll again be able to cancel something. So if n turns out to be even, and then I can cancel 2n n. If n plus 1 turns out to be even, then I'll be able to cancel this n plus 1 or n 2. But in any case, the final expression which we got for n plus 1 by 8, just one sec guys, n plus 1 by 8, I can surely say that the remainder is 0. So I don't need to be dependent upon values to find this out. I just show it to you just for the sake of convenience to help you understand it. But keep in mind, I always prefer the general way, because that tells you definitely what is possible, what is not possible. You may even try it with 2n minus 1. I'm not going to do that, but you'll notice that you're getting similar expression. Okay. So I hope this is perfectly clear, and I hope through this question also you've understood why it is important to do a brief analysis before finding out the answer. Doing the analysis will definitely going to help you, pre-analysis definitely going to help you solve the question very quickly, very easily under 2 minutes. Okay.